Momentum is mass in motion and depends on mass and velocity of an object. It is also a vector quantity, which means it's in the same direction as its velocity. The equation is P equals mv, which is P momentum equals mass times velocity, and the units are kilograms per meters per second. For example, a 1,000-kilogram car accelerates from rest to 30 meters per second. Find A, the initial momentum, and B, the final momentum. For initial momentum, the equation is P1 equals mv. We know the mass is 1,000 kilograms, and since it's starting from rest, the velocity is 0 meters per second. And so multiplying the 1,000 times 0, you get an initial momentum of 0 kilograms per meters per second. For the final momentum, we use the same equation, P equals mv. We know the mass is the same at 1,000 kilograms, but the velocity changes to 30 meters per second. So multiplying the 1,000 kilograms times 30 meters per second, you get 30,000 kilograms per meters per second as your final momentum. Impulse is the product of a net force and the time over which it acts. The equation for that is J equals F net times T, which is also equal to the change in momentum. J is impulse, F net is the net force, and T equals time. The units for this is kilograms per meters per second, which is the same as the momentum units. To do an example, a ball is stopped by a 100 Newton force over a time period of 2 seconds. Determine the impulse. The equation we use is J equals F net times T. We know that there's a 100 Newton force and it took 2 seconds. So you take those two numbers, plug them in for F net and T, multiply them together, and you get 200 newtons per second as the impulse. Now we have to relate impulse and momentum together. According to Newton's second law, an unbalanced force acting on an object causes it to accelerate. This acceleration produces a change in the object's velocity and consequently its momentum. The equation we would use for this is J equals F times T, which is equal to the change in momentum, which is equal to mvf minus mvi. Mvf is the mass times the final velocity minus the mass times the initial velocity. To put this in a real world terms, an airbag stops a person by spreading the force over a greater time, therefore decreasing the magnitude of the force acting on the person, since the change in momentum would be the same, whether there's an airbag or not. To do an example, a force of 20 newtons acts on a 3.5 kilogram object for 10 seconds. Let's find A, what is the impulse, and B, what is the change in speed. To find the equation, or the impulse, we're going to use the equation J equals F net times T. We know there's a 20 Newton force being applied over 10 seconds. So we take 20 newtons and multiply it by 10 seconds, and you get an impulse of 200 newtons per second. To find the change in speed, we're going to use J equals M change in V, which is mass times the change in velocity. We know the impulse is 200 newtons per second, and the object is 3.5 kilograms. So to plug that in, it'd be 200 newtons per second equals 3.5 kilograms times the change in velocity. From there, you divide 3.5 kilograms from both sides to get the change in velocity, which ends up being 57.14 meters per second. Now on to elastic collision. Elastic collision is defined by objects that collide and move with different momentums. The equation used is MAVAI plus MBVBI equals MAVAF plus MBVBF. This stands for the mass times the initial velocity of object A plus the mass times the initial velocity of object B equals the final velocity times the mass of object A plus the mass times the final velocity of object B. For example, a 3,000 kilogram truck traveling 10 meters per second collides with a 1,000 kilogram car at rest. After the collision, the car travels with a speed of 15 meters per second. Find the speed of the truck after the collision. It's easiest if you draw a picture for these equations using boxes labeled A and B just to keep your work straight. So we're going to use the equation MAVAI plus MBVBI equals MAVAF plus MBVBF. We know that the mass of object A is 3,000 kilograms, and the initial velocity is 10 meters per second. And the mass of object B is 1,000 kilograms, and the initial velocity is 0 meters per second, and the final velocity is 15. Plugging this into the equation, we get 30,000 equals 3,000 times VAF plus 15,000. Subtracting 15,000 from each side, you end up with 15,000 equals 3,000 VAF. Subtracting 3,000 from both sides, you get a final velocity of 5 meters per second for object A. Our last topic is inelastic collision. Inelastic collision is when objects collide and move off with the same velocity. The equation we use is MAVAI plus MBVBI equals MA plus MB times VF. This means the mass of object A times its initial velocity plus the mass of object B times its initial velocity equals the mass of object A plus the mass of object B times the final velocity. For example, an 80-kilogram grandma traveling at 6 meters per second on roller skates collides with her 40-kilogram grandchild initially at rest. After they collide, she picks him up and they walk together. Find the speed after they collide. For this problem, we know the mass of object A is 80 kilograms and the mass of object B is 40 kilograms. And the initial velocity of object A is 6 meters per second and 0 for the second object. So then plugging it into the equation, you get 80 times 6 plus 40 times 0 equals 80 plus 40 times x. And after adding both sides together and dividing to get x alone, then you get 4 meters per second as the final velocity.